Lesson 8 Project Help video. So we have the rational root theorem. Let f of x be a polynomial with integer coefficients. If the leading coefficient of f of x is a, then the constant term is b not equal to 0, then any rational root of f of x has the form s over t, where s is an integer factor of b and t is an integer factor of a. So we're going to use the rational root theorem as we go throughout this video to help us determine whether or not we have some possible rational roots. As Farmer Frank continues to organize his farm, he finds that some of the crops are in fact polynomials. Their roots are actual roots of polynomials. Some of the crops have rational roots and some have irrational roots. He needs to discover which crops are which so he can start untangling these beasts and getting rid of the little vermin infesting the lower levels of the farm. So the first crop the farmer examines has a label of 0 equals 2x cubed minus 5x squared minus 7x plus 1. He digs up the roots of several crops. What are some possible rational roots for this crop? So the rational root theorem said that if we take the factors of our constant term here over the factors of our leading coefficient, then that will give us our possible answers. So our possible roots of positive 1 are plus and minus 1, because we could have 1 times 1 is 1, or we could have negative 1, negative 1. Now over our possible roots of 2, well, our factors of 2 are 1 and 2. And we're going to use the positive and the negative of those. So possible roots that we could have is a positive 1, a negative 1, because if we do 1 divided by 1, we would end up with a positive 1 or a negative 1. And then we also have a 2 there in the denominator, so we could have 1/2 or negative 1/2, because we got the positive or negative in front. So these are our possible rational roots for this crop. The farmer is able to trace the next crop's roots to find that one of the roots is 3 plus square root of 5. What value must another root of the plant? Well, if you remember the complex conjugate pairs that we have to have when we find roots, that theorem, the complex conjugate root theorem, says that we have to have, if we have the root here of 3 plus root 5, that must mean that instead of a plus in between, it must also be a root of 3 minus root 5. We have to have both, the positive and negative of the root there. So another possible root would be 3 minus square root of 5. The farmer traces one crop's roots to discover that it has exactly 5 roots. One of the roots he can trace to is 4 minus 5 root 3. At least 2 of the roots are the same and labeled 7. What conclusions can the farmer draw about the other 2 roots? Well, just like in our last one with the complex conjugate root theorem, if we have 4 minus root 5 over 3, that means we also must have 4 plus 5 root 3. So that would be another one. So that gives us 1 of them, 2, and then it says we have 5, so that means we need 3 more. It says here there's at least 2 of the roots are 7. So we know then that this would be our 3rd root and our 4th root. So we need to know what's our possibility for our last root, our 5th root. Well, it says at least 2. So that means that there might be only 2 of them. There could be 3, 4, as many as we need. Since there's 5 roots and we have 4 of them, we only need 1 more. So another possibility here for our 5th root would be 7. So these are our 2 possible roots that the farmer can draw a conclusion about, that those might be the other 2 roots that we have. The farmer examines one crop and can't seem to locate its roots. The crop is labeled as p of x equals x squared plus 3x plus 6. Which value should the farmer test to see if the crop has rational roots? Well, if you remember from the rational root theorem, we're going to take our factors of our constant term here, 6. So those factors are 1, 2, 3, and 6. And then over our term factors of our leading coefficient, which is 1. And remember that we have the plus or minus of each of those. So, since we have just a 1 on the bottom, if we divide anything by 1, we end up with just itself. So that means that we're going to end up with possible roots being plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Those would all be our possible roots that the farmer would need to test to see which ones work. So hopefully this helps you out. That's the end of our lesson 8 project video. As always, if you need more help, feel free to contact me.